Hello and welcome back to another video about the libretto. Previously we had looked at a number of librettos that I had got shipped from Japan, and they all worked except for this Libretto M3, which really shows no signs of life other than the power light coming on when you turn it on, but it doesn't make any sounds and nothing comes up on the display. So I thought, what better way to solve this problem is to get another M3. So here we have an identical M3 right next to it. And this one does actually turn on, and this one does actually boot. So I thought we would take a look at potentially swapping some of the hardware, doing a display swap between these two units and seeing if that potentially is the problem. Other than that, there were appeared to be some modifications to this M3, which kind of seemed to center around potentially the CPU multiplier or something to dealing with the frequency for the CPU. Since it seems like that's where that is connected on the main board. And I just wanted to see if this unit has that same modification. And if so, then we would know that that's a factory thing. And if not, then that might actually be some sort of aftermarket modification that we can remove, and potentially that is preventing this unit from booting. So I wanted to go ahead and take a look at this M3 that is working. As you can see, it's identical. The only thing is that somebody has removed the Docomo label over here, but it still says Libretto M3 for Docomo here. And if we open up the unit, we can still see Libretto M3 for Docomo. So I thought we would go ahead and power this unit on and just get a general idea of what the behavior is, and we will go from there. Okay, so I'm going to go ahead and connect up power to the side here. And we should see the lights come on. Okay, yep, we have the power and we have the battery charge light. So if I go ahead and press the power button, and yeah, we can hear that hard drive start to spin up immediately. I'm getting the CMOS error, most likely because the CMOS is just dead. So I'm going to press F1, and I'm just going to do function end and save. And this unit actually should boot right up. Look at that, Windows 98. So we have a working M3 here. So that's really good news. The display is a little dim. So I'm wondering if we can fix that in the future. But either way, I think we will go ahead and start using the parts from this one, namely swapping this top display portion to the other unit and seeing if that gives us any progress. So let's let this boot up, and then I will shut it back down and we'll take a look. Okay, so we're fully booted into Windows 98 here. Looks like there is some pretty cool screensavers and backgrounds specifically for Docomo. So I would like to back those up because I don't think those have been archived anywhere. So we'll go ahead and shut down. And of course all of this is in Japanese, but after using these for a little bit, you start to get an idea of what the dialogues are saying. What's helpful is that in a lot of cases they have this the Alt key for what these are. So like S here is just shut down. So we'll go ahead and shut down and take a look. Okay, so with the unit shut down, we're going to go ahead and remove power. And we will go ahead and start removing the keyboard. And so the first step here is to go ahead and remove this little retainer. And you have to be real careful because these can snap. So there we go. And we will remove this screw on the keyboard. And that should just lift right up. And here we see the inside. Looks very similar to the other unit so far. And we'll go ahead and remove the keyboard, these two clips on either side. Okay. And we will pull up our clip for the keyboard cable. Okay, there we go, keyboard. So we want to go ahead and disconnect our display cable, just so we don't forget. Okay. And flip the unit over and remove the screws from the bottom. And go ahead and remove these screws. All right. So now if we remove this battery, the unit should just go ahead and come apart. So we'll slightly separate our sides, and there's a small crack right here. So we'll be very careful with this. That broke off. Dang. Okay, well, hopefully we can reattach this with some epoxy. But here is the top removed. And we get a better look at the motherboard. So what's interesting right off the bat is that I don't see the additional capacitor that was added here. And I don't see any evidence of that ribbon cable modification that's on the other unit. So that really has me wondering, although I do see some leakage from the original CMOS battery, which has been removed. So we're going to want to clean that up just so that that doesn't cause any additional damage. But let's go ahead and get the other unit open. Set this one up here. And we'll go ahead and do the same thing. We'll remove the keyboard. And I don't think I put the screws back in this one, so this one should come apart a good bit quicker. So there's the keyboard. And we'll disconnect the display cable. And then we'll remove the battery. And so an interesting note is I ordered this other M3 from the same supplier, JOS, which is a proxy for the Yahoo Auctions Japan. And they normally have a policy about shipping batteries where the batteries have to be contained within the original device. And so this M3 actually came with a spare battery. And I was hoping that wouldn't be a problem, and it looks like it wasn't because they just removed the battery from this casing. So I have an empty battery shell. So that is actually kind of useful because the battery does provide some retention to keep the case together, especially when you don't have screws in it. And when opening the Libretto, typically you kind of pull down in this area here, and we don't want to snap the plastic, so that actually does kind of help, although I wish I had got the actual battery. So with that, we should be able to lift the display section off. These are always quite fiddly, especially because we don't want to break it any more than it already is. Okay. So that should lift off. All right, so here, all right, So here we have the two M3s, and this is the one that is not working. And we have here this capacitor that's across some of the connections on the battery, and I don't think this is causing any particular issue. But what has me interested is this modification where these two wires are connected to this component, which looks like a capacitor. And then it runs to this ribbon cable that is underneath this little protector here. Okay, and if I zoom in a little bit closer, here we see that modification with the ribbon cable, and I'm just going to go ahead and lift up this little bit here. And that reveals the graphics chip and some of this ribbon cable modification. So, and then we should be able to lift the board out, and you can get a better look at this modification here, which runs over to this chip right here. So I think the first thing we want to try is just using the display section from the working M3. I'm fairly sure that the displays are compatible with the other Libretto 50 series, but since we have a working M3, we'll just use that one just as a quick test. Okay, so move the other M3 out of the way, and we will place on top our working M3 display. And we will insert our blank battery just to help hold the case together a little bit. And open that up. And connect our display. And we'll apply power. And so the power light has come on. So we'll go ahead and turn this on and see if we get any activity. And nope, same behavior with the display, just not displaying anything. The power light comes on, but the hard drive light never has any activity, and no sounds out of the unit. So we'll just go ahead and remove our power again. So the first thing I think we're gonna try is disconnecting some of this modification here, because that very well could be preventing the CPU from working, or it could just be conflicting in some way that is causing it to not start up. So I'm going to remove our motherboard. And we'll heat up the soldering iron and give that a test. Okay, soldering iron's all heated up, so I think what we'll do first is try and remove these wires here. So we'll take our tweezers and apply a little bit of heat, and hopefully these wires will pop off. Okay, that's one. And we'll do this other wire. If I can get under the wire. Right. So we have those two wires disconnected. I'll just move these slightly out of the way. And on the other side of the board, we have this connection here. But I'm pretty sure this will be doing nothing because the two wires just run to these two what look like resistors. And they are not connected to anything else, so that should have removed this modification from the circuit. So let's get out our display and see if this thing has any sign of life. Okay, so we have the display section, and I was hoping that would reach, but that doesn't, so we will bend this all the way down and just kind of place it on top, get our display connected. There we go. All right. So display reconnected. So we should just be able to apply power. So we'll plug in our power cord. Okay. And we get the green light for power. So we'll go ahead and hit our power switch. And nothing. Still nothing out of the display. We do have a power light, but I don't see any activity on the screen. So it was not that simple. Okay, before we move on, I just want to go ahead and take the hard drive out of the working M3 and put it into this unit just to make sure that that's not causing a problem that sometimes prevents the librettos from starting up or showing anything on the screen at all. So let's do that. Okay, so here's our other M3, and we'll just go ahead and remove the screws, holding down the board. Okay, that's most of them. All right, that should let the board come out. There we go. Okay, and now we can actually get a better look at this chip down here now that there's not something on top of it. We have our original Toshiba hard drive. And the way to remove that is it's actually held using the same clips that hold the memory module. So we'll go ahead and take these screws out. And that should let our hard drive come free. And again, you have to slightly lift up on this side of the hard drive and wiggle it out. It has to clear the power circuit or these components in this area. So there's our hard drive, and we'll set our working motherboard aside. And we'll get our kind of hodgepodge unit out. And now we will go ahead and just connect this hard drive to this unit. So we know that this was working well enough to boot. The hard drive does sound like it's on its last legs. So let's give this a try. So now that we have the hard drive installed, we'll go ahead and reconnect power and see if we can get any life. Okay, so the hard drive spun up. So it definitely means that enough of the components on the board are getting power, but still nothing out of the display. So far, not so good. Give this just a second, but it certainly seems like we still have the same problem. Okay, and before we move on to further investigations, I wanted to check if this libretto, like a lot of the others, will not start up without a hard drive installed. So we're just going to take our other display unit from the non-working M3, and we'll go ahead and open up the display. Like so. And we will reconnect our screen. Okay, and we'll go ahead and connect power. Okay, so we are getting the In Touch with Tomorrow Toshiba screen. I know that's not really coming through, but we are actually seeing something on this screen. So at least we know the screen works. So that's really good news. So yeah, this one will at least turn on without the hard drive installed. But now we get the IDE error. So there's no hard drive present. So we know we should at least be able to get to the BIOS screen without having a hard drive installed in the M3. So that's a little bit different than the Libretto 50 series that won't power on at all without a hard drive installed. Okay, before we proceed any further, I wanted to test removing the this other capacitor here, which is across the battery terminals, just because it's a modification we see on this unit that we don't see on the other. So I'm going to lift one leg of this capacitor. Just want to remove anything that seems different between the two units. So there we have one leg lifted, and let's give this a test and see if that makes any difference. Okay. Okay, so we've reattached our display assembly, and we have disconnected the modification down here, and we've also disconnected a capacitor that's right here across the battery terminals. So go ahead and apply power. And we do hear the hard drive spin up. But again, no signs of life, nothing on the screen, and no apparent attempt to access the hard drive, although it is spinning up. Okay, since neither disconnecting this capacitor or disconnecting this modification over here seemed to have any effect, I want to just go ahead and reconnect those so it was back in the state that we found it. Go ahead and reconnect this capacitor here. And we will reconnect these two wires back onto our capacitor. What I believe is a capacitor. Okay, so I've reassembled the non-working M3. I took the hard drive out because doesn't seem to be required to get the M3 to post, as we saw with the working unit. And I went ahead and put the blank battery back in just to help hold the case together. So let's try something else. Okay, so here we have the M3 that is not working. And if you enjoy this kind of content, I would strongly appreciate that you like and subscribe. It definitely lets you know when there's future content, and it helps me know what kind of videos people are interested in. So with that, I actually got, for the M3, the one that is working, I got the dock. Now this is extremely rare, in addition to how rare the M3 itself is, because it uses a proprietary dock connector that seems to only be compatible with the M3. And this one is in rather rough shape. So as you can see, I have taped it back together with some painter's tape, and it has some quite severe damage from shipping. But the other interesting thing is that this is mostly empty. The board is only in this area. It does not have additional card slots on the side, like a lot of the other Libretto docks. And it does not even have a power input, but it does have a USB port, and it does have a parallel port. So thanks to a suggestion on another video, that we take a look at using one of the parallel port postcode readers, because apparently the Toshiba laptops do support sending BIOS status postcodes through the parallel port on startup. And to do that, we will use an adapter like this. So this is actually something that I put together about 20 years ago, almost. And the purpose for this at the time is that I had a computer and I was writing some Winamp plugins, and I wanted to do some lighting effects on the inside of the case. But things like the Arduino didn't exist yet. There was really no way to easily connect those kind of things up over USB. So I used a parallel port on the computer and some transistors and some larger LEDs to create reactive lighting on the inside of the case. And so I wired this up as a tester to make sure that the software was working. But here I have 8 LEDs hooked up to the 8 parallel bits on the parallel port. So with this, hopefully we will see some status out of the Libretto. So the first thing I want to do is, this is the non-working unit. So I want to take the working unit and connect that to the dock and hook up the parallel port. And we'll take our parallel port adapter here and we'll connect it to the dock. So I have the working M3 unit connected to the docking station. There's no power input on the dock itself, but what we'll do is we'll go ahead and connect our parallel port LEDs like so. And try to get a good view of this. I'm going to open the display slightly just so I could get to the power button. And we'll connect power. And let's see what we see. Okay, so I can see these LEDs, but barely. It seems like they're very low power. And unfortunately, the lights are washing that out. So let me see if I can get the lights either a little bit dimmer or some shadow on that and see if we can get a better look. But currently, all of the lights are lit up. And the Libretto is at the IDE error because we didn't put the hard drive back into this unit. But we are getting information on the screen. Okay, I can't seem to find any good combination of lighting that'll let us see this easier, but I'm going to go ahead and connect the other Libretto, the non-working M3. Okay, so I'm going to go ahead and connect the non-working M3 to the dock. Helps if you lower that. Okay. And the case is very precariously put together. I haven't put all the screws back in because I imagine we'll be back on the inside. So what I want to see is if there's any difference in the parallel port readout when this unit is not starting up. So let's go ahead and start this up. Okay, I do see activity on the parallel port. Okay, so looking at this, I have the non-working M3 turned on. It is stuck at blank screen. And I can see here on the parallel port, if I cover this slightly, that the first and the third LED are lit up. So let's try and find the manual, although I can't find any manuals for the M3. I wonder if one of the similar librettos in this line have a diagnostic for reading out these parallel codes. So we have the first LED and the third LED lit up. And that would be a binary 5, so 1, 2, 4. So 1 plus 4 is 5. And that would also be hex code 5. So let's see if we can figure that out. Okay, so I thought a good place to start looking would be at the maintenance manual for the Libretto 50 and 70, because this M3 is at least in the same form factor. So we will search for parallel in this document and hopefully find, aha. So here's actually the official Toshiba version of the same thing we've built. And it says that it will show the status and test codes and that there's a table. So if we scroll down to the table, we see that 05 hex, which I believe is how we decoded our LEDs, is that this says it's being stuck at the SMRAM check. We'll have to look that up because I'm not actually sure what function SMRAM provides in the system. And then I thought we would take a look at the Libretto 100 manual, because this hardware is a little bit closer to a Libretto 100 than it is a Libretto 50 series. So let's take a look in this manual and see if this has anything different or if it's the same. Okay, so this is quite a bit different. Looks like 05 is responsible for quite a number of things. SMRAM is in this same list, but this could really be anything from a corrupted BIOS. Although if it's writing status codes, then we have to imagine that the BIOS is at least starting up enough to be able to produce these codes. If the BIOS wasn't present, we wouldn't get any of this out of the parallel port. So it must be getting stuck somewhere here. I don't know if it's that SMRAM error that we're seeing from the Libretto 50 manual, but this at least gives us a place to start. So I think we'll go back to the Libretto and start taking a look at some of the chips on the board and see if we can identify where this problem may actually lie. And before we move on, I think I'll search this document for anything pertaining to SMRAM. It looks like, no, these are only in this table. And let's see if it's the same thing in this. So yeah, the only occurrence of SMRAM is here on 05. And I just did some Googling trying to find what precisely the SMRAM is. I don't know if that just means the main system memory, although you would think that's labeled something different, but I did find it in a few of the other Toshiba maintenance manuals, but I can't find any other mention of what function the SMRAM is or where that might be present on the motherboard. Okay, so I found this document, the hardware configuration interface on Toshiba laptops. I'm not really sure where this document comes from, and it was no longer available at its web address, but thank you Wayback Machine at the Internet Archive for archiving this document. And the only mention of SMRAM that I can find has to do with something relating to the hibernation feature. But I can't really say why this makes any difference with why the machine is not starting up. Obviously, it can't think that it's being hibernated or asleep if there's no BIOS battery. And yeah, so this is very strange. Okay, so now that we've taken a look at the maintenance manual, I wanted to start taking a look at some of the chips that are on this board, and what I'd like to do is find the BIOS chip at all, because it really still could be some corruption in the BIOS, and if we can flash that manually, that may provide us a way to restore this machine. So I've started taking a look at some of the chips. I'm going to ignore some that are obviously not a BIOS chip. So like here we have the main system RAM, display controller. This is some sort of a bridge chip, north bridge, south bridge type situation, platform controller, what have you. So if we start taking a look at some of these chips, this one here, this CY2278APAC, this appears to be a Pentium 2 clock synthesizer chip. So I'm not really sure why that's being paired with the Pentium 1 that's in this machine, but either way we can pretty much assume that that is not our BIOS chip. This is our sound controller, which is a Yamaha YMF 715F. And here, I think this may be one of our best culprits for a BIOS chip, because this is a 4 megabit or 512 kilobyte CMOS flash, and this has a part number of 29F400TC. So that is certainly a strong contender. Although what's interesting is it looks like most of its address or data lines, or at least a number of them, are connected to this chip over here, which is interesting in its own way. This is a M38867E8 AHP, or an 8-bit CMOS microcomputer. So this appears to be some sort of a microcontroller that has most likely been flashed with some sort of a firmware. So that talks to this chip here. So I wonder if the signaling is going through this platform controller here to this 8-bit CPU, and then to this BIOS chip here, if this is indeed the BIOS. And I think we'll take a look at the other side of the board and see if we can see anything interesting. Some of these 4 or 8 pin chips here, they seem like they could be some form of SPI flash, but most of these appear to have pretty significant traces running to them. So these are probably power management ICs for regulating power flow to various parts of the board. So let's go ahead and flip the board over and see if we can find anything else interesting. So on the opposite side, we have this chip right here, which is a MIC2563A. And this is a power management controller for the card slot, the PCMCIA card slot. And again, we have some of these 8-pin chips that have hefty traces, so most likely for power control to other parts of the board. And that's kind of it, but I did notice that there's a good amount of space underneath this PCMCIA socket, so I wanted to go ahead and remove this cage and see if we can take a look underneath to see if there's any other interesting chips underneath here. So we'll go ahead and flip this back over and remove our heat shield. So this little plate should lift right off, and this is right over the CPU. And if we flip it back over, we should be able to remove this piece of metal. The card slot connector here is soldered directly to the board, so that is not easily removable. But it looks like if we pry these clips on either side, that we should be able to get this off. Okay, there we go. All right, so that should come right off, and it does. And then there is some plastic protector here, and we should just be able to peel this away. Okay, that's not very stuck on there. All right, so there's a number of interesting chips underneath here. So let's look these up and see if we can find out what these are. Okay, so these NEC chips, these are labeled D43123LGF-A8, and these appear to be 1 megabit SRAM, so 1 megabit or 128 kilobytes. So most likely this is 256K of cache for the CPU, which makes sense because it's rather close to the CPU over here. This Toshiba chip, I can't find anything about this, but you have to imagine that if this is a Toshiba labeled chip, that it's some sort of custom silicon for this particular machine. So we don't really know what this is, and the same goes for this chip over here, which, if I'm reading the markings correctly, reads IMP87PH48U, and I can't find any information about this chip either. So we have a number of unidentified chips on the board. So I think that kind of leaves our best culprit for a BIOS chip to be this one right here, which again we identified as a 4 megabit or 512 kilobyte flash chip. And before we move on, I did want to take a look at, I got the part number of this chip here that is covered up with this flex cable by reading it off of the other M3 that does not have this modification. So this chip is an MM1089, and it appears to be some sort of differential amplifier. And I can't really say I understand what its function is in this whole circuit, but it is definitely not a flash or memory chip. So yeah, I have to think this has something to do with clock frequency generation or multiplier settings for the CPU, because I've seen this kind of modification in other librettos where people are overclocking the CPU of the libretto. Typically, Toshiba will have sometimes put in higher speed CPUs just as a cost reduction in some of the other models, and there are sometimes ways to increase the clock frequency or the multiplier and get additional speed out of the CPU. But we did try disconnecting that, and it did not appear to make any sort of difference. So I think we may end this here. I am going to start trying to find a way to connect some probes to this flash chip and see if there's a way that I can get access to the memory on board. I can most likely dump the BIOS from the other working M3 and use that as a reference point against this chip and see if there's any major damages or differences in that readout. But until that time, I think we'll end this here, and please let me know if you guys have any ideas. I'd really like to hear about it in the comments. I'm anxious to get this rare M3 working again. So, thanks for watching.